Hi guys, welcome back. We are looking at lesson 3 in chapter 8. And this is again going to be multiplying a fraction by a whole number. So it's our kind of our third part in doing this. The first time we looked at multiplying a fraction by a whole number, but that fraction had to have a 1 in the numerator. So maybe we did 7 times 1/3 or something like that. The second lesson that we looked at multiplied a fraction by a whole number, but this time that fraction could be anything. It didn't have to have a 1 in the numerator, so maybe this time it would be 7 times 3/5, right? So this is not a 1, whereas here it is. This time we're going to look at multiplying a fraction by a whole number. We're going to look more at this type of case where there's not a 1 in the numerator, but the thing that we're going to do that's different is, if you remember in this last lesson here, and this isn't a good example, let me say that we did 5 times 3/10. Maybe that would be our example from the last lesson that we would look at. Hold on, I didn't even see whether I could focus this first. Okay, hopefully that's better. Last time we would have multiplied across and said that we have 3 pieces out of 10, and then we're doing that 5 times. So we would get 5 sets of 3, or 15 tenths. And then we had to do 2 things. One is change this into from an improper fraction into a mixed number, and the other thing we had to do was reduce. So here we would say that this is the same as 1 5/10, and then we would reduce this and notice that 5 went into both 5 and 10, and we would get 1 1/2. What we're going to look at this lesson is doing the reducing before we multiply. And again, the numbers right now are small enough that it's not that big of a deal whether we reduce first or second, but I promise you that once we start doing bigger numbers, you are definitely going to want to reduce first. So let's take a look at the lesson with that in mind. We're going to know how to do the multiplication already, but the new part is going to be how to take care of that reducing before we multiply. Okay, so the problem that we're going to look at first here is the distance around a track is 3/8 of a mile. Dion ran around the track twice. How far did he run? And they asked the question, how can we use multiplication to solve this problem? So hopefully you would say, oh, well, it's 3/8 2 times. All right, so I'm going to do 2 times 3/8. All right, let's look at the top of the next page because they are going to start telling us methods that we can use. So the first method that they look at is to just say, well, here's 3/8 and here's 3/8. And if we do that twice, all right, so they're just going to do 2 times 3/8, they get 6/8. 1, 2, 3, 4, 5, 6. But then what they do is something unusual here. They say, well, let me take, instead of looking at it as 3 and 3, let me look at it as 3 sets of 2. So then including this part that's not shaded in, I end up with 4 sets of 2, and 3 of them are shaded in. Now, why the heck would they do something like that? Well, it really comes from this. I wouldn't know, I wouldn't necessarily think to do that just from looking at the bar graph that they gave us right here, the bar model. But when I look at this, I notice that 6 and 8 both share a common factor of 2. And so if I divide both 6 and 8 by 2, I end up with 3/4. So really what they did here is just draw a visual representation of what they know is going to happen when they reduce right here. So when 6/8 is reduced, it is the same thing as 3/4, and instead of drawing it like 6 pieces out of 8, they did the easier method, which is 3 out of 4, because it's the same amount that's shaded, but it just means that we have to draw less sections. All right, we shade in the same amount, but with fewer sections. All right. So again, we multiplied, we got 6/8, and we reduced. So then what we're going to do in the second method is what I was telling you first back on the previous page about how we reduce first. So before we multiply, all right, when we're in this stage right here where we've got 2 times 3 divided by 8, what they do is they say, hey, look at this. 2 and 8. Before I even multiply, I notice that 2 and 8 share a common factor of 2. right? 2 divided by 2 is 1. They cross out that 2 and write the 1 to show that after I take out that factor of 2, I'm left with a 1. And then down in the denominator, they do the same thing. I take out a factor of 2 from 8, and 8 divided by 2 is 4. Now, once we remove that, again, this is before we've ever done the multiplication. Once we remove that, now we say, okay, now we're ready to multiply. And I'm going to take that 1 that was up here times the 3 and get 3. And that 4 that's left over, there's nothing to multiply it by. It's just a plain old 4, so I'm just going to transfer it right over here. Okay, so we end up with 3/4. So instead of multiplying and then simplifying, what we did was simplify when the numbers are smaller and then multiply. Okay, so right here they say we can simplify the calculation by dividing the numerator and the denominator by the common factor in the same way that we simplify fractions. So essentially what we're doing is we're taking and we're doing the simplifying here rather than here after we get the answer. And again, the advantage of doing that is as we get bigger and bigger numbers in our fractions, it's going to be easier to simplify before we multiply when we have smaller numbers than after we multiply when we get bigger numbers. And let me just show you an example like that. So let's say we had 16 times 3/8. All right, so let's say instead of 2 times 3/8, we had 16 times 3/8. So we would write this as 16 times 3 over 8. Then we would have to do 16 times 3, which you probably don't know, so you'd have to do it over on the side here. And you would get 48. And you would have to do 48/8. And you would have to reduce that. And you would have to say, okay, what do 48 and 8 have in common? And maybe you would start with 2, and then you would divide both of them by 2, and you would get 24/4. And then you would say, what do 24 and 4 have in common? Maybe you would recognize that they have a 4 in common, so then you would just say that this is 6 and this is 1. Right? But if we did it at this point, right? So when we still had 16 times 3 over 8, if we did it at this point and we said, hey, 16 and 8, I know that. 16 is in the 8 family because it's just 8 times 2. Then I can say right off the bat here that 8 and 16 share a common factor of 8. This becomes a 2. This becomes a 1 as we divide that 8 out, and I just end up with 6 over 1. So when those numbers are bigger, like this, 16 and 8, it saves us a lot of time by doing the simplifying first while they're still small, rather than multiplying, getting a big number, and then having to find the common factors between a big number and 8. All right, so again, that's our reason for doing that. Even if right now it doesn't seem like that's going to save you that much time, I promise you it will. Okay. So let's say we can simplify the calculation by dividing the numerator and the denominator by common factors. We just read that already. So we find the factors of 2, which are 1 and 2. We find the factors of 8, which are 1, 2, 4, and 8. We had a lot of practice with this before we went out to working from home. So again, we have to remember all our divisibility rules here. If again, these are small numbers, so hopefully you remember them. But the greatest of all the common factors is 2. And so when you divide both 2 and 8 by 2 and then multiply, you get 3/4. So he ran 3/4 of a mile. Okay, let's take a look at the next page. Find the product of 3 and 2/9. So again, they're giving us a visual model here. This bar right here is broken up into 9 equal pieces, and they're breaking it into groups of 2/9, right? 2 lightly shaded 2/9, or lightly shaded ninths, 2 dark ones, 2 light ones, so that you can see the 3 separate sets that we're talking about. All right, again, they wrote it as thirds by doing that regrouping. Again, I'm not sure that I would think to draw it that way again, but they do it because they know that what the answer is going to be. So let's go through and do the canceling. All right, so I'm going to write it over here. 3 times 2/9, I'm going to write the 3 times 2 over 9. Again, I'm looking, it doesn't matter that whether it's this pair or this pair, but I'm just looking for something that shares a common factor. And 3 and 9 both share that common factor, and the common factor is 3. So I'm going to divide both of them by 3. When I do that, all that's left of the 3 is a 1. And when I divide 9 by 3, all that's left is 3. right? Then 1 times 2 is 2. And then there's nothing to multiply the 3 by, it's just a 3. And then we get 2/3. And visually, what they've drawn for us is we can see that we have 2 out of 3 shaded. And so here we would also write 2/3. And again, how do we know that we're going to divide by 3? These numbers are small enough you probably could figure that out, but if you didn't, you would just list the factors like we have done so many times and say the factors of 3 are 1 and 3. The factors of 9 are 1, 3, and 9. That is the greatest of the factors that they have in common, and that is what we would use. All right, so again, when the numbers are small like this, you probably can do it in your head, but when they get bigger, you're definitely going to want to write them out. Okay, problem 2 here. Find the product of 5 and 3/5. So here are 3/5. There's 3/5, 3/5, 3/5, 3/5, 3/5, and we've done it 5 times. 1, 2, 3, 4, 5. Now they've regrouped them so that you can see how they make wholes. So we've taken 2 from here and added it to get this. We've taken this 1 and given it to here, and this 1 and put it here to get another whole 1, and then these 2 that are left and put right here. Okay, so we end up getting 3 wholes. So visually we can see what the answer is going to be. It's going to be 3. But let's do that mathematically. So again, I'm going to write it over here. 5 times 3 over 5. So I want you to see there are the 2 things that share a common factor. They both have a 5 in them. All right, so when I do that, I'm going to take 5 and divide a 5 out, and all that's left is 1. I'm going to take the 5, divide a 5 out. Again, that's the common factor. All that's left is 1. Now I'm going to multiply across. So 1 times 3 is 3. There is nothing but 1 right here. And again, we don't usually write it as 3 over 1 unless it helps us visually. But normally we would just write that as 3. All right, so we can see mathematically that we got 3. We can see visually that we get 3 when we rearrange them so that they make whole circles. All right, so the answer here would be 3. Okay, let's take a look at the last page of this lesson. All right, find the product of 6 and 5/8. All right, so 6 and 5/8. Again, they've got the 6 times the 5 because we're doing numerator times numerator, denominator times denominator. And again, they're looking at the 6 and the 8 for right now because it's a whole number times a fraction. It's generally going to be the whole number and the denominator that have the common factor, but it won't always be that way. Sometimes it'll be this. Okay, so we're going to look at 6 times 5 over 8. This is the pair that shares the common factor. Again, if you can look at that and say they're both even, they share the common factor of 2, that's great. If not, you should list out the factors and find out what the greatest common factor is. All right, and again, we use the divisibility test to do that, or just our times tables. All right, so here the greatest common factor is 2. So we're going to say, okay, let me divide out that common factor. 6 divided by 2 is 3. So they've got a little box up here. They're assuming that you're going to write a 3. And then 8 divided by 2, the common factor, gives us 4. And they already wrote the 4 there. Now we're going to multiply across by whatever's left over. So we have the 3 here after we took the 2 out of the 6. We have the 3 times the 5. That's 15. And then we just have a 4 in the denominator. Okay, we still are going to often have that step of doing the improper fraction to a mixed number, but the advantage is we're not going to have to simplify 2 after that. We'll just have to fix that, change it into a mixed number. So now we're asking ourselves the question, how many groups of 4 are there in 15? Right? There's 2 ways. You can just skip count and think 4, 8, 12, 16. Oh, 16 is too much. I only have 15. So 4, 8, 12. So there's 3 sets. And to get from 12 up to 15, there would be 3 more out of 4. Or you can do the division method. How many times does 4 go into 15? It's 3 times. Remainder 3. So this 3 right here is the whole number part, and this 3 is the numerator. Again, our fourths, our size of our piece never changes, so that should always match. Okay, but again, we don't have to reduce at this point because we did the reducing first. Okay, how about you try and do the multiplying part here? So pause for just a second and see if you can figure out what the common factor is between 8 and 12. Now, I do want to point out one thing. Notice how in all the other problems that we've done so far, they've written the 6 and the 5, or whatever this whole number was, and the 5 together in the numerator first and then over the denominator. Here, they're not even bothering. They're just kind of looking at this part and saying, I know that this is what I'm going to be canceling out. And so they skip that step of writing them together, all right? So just a little baby step they do that's different, but they're just saying, instead of writing them together, let me cancel first before I even write them together. All right, so pause and see if you can figure out what the common factor is and what this fraction would be right here, and then come right back. Okay, so hopefully you realize that the factor that they share is 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. Again, they kind of write it all out for you here. Factors of 8 are 1, 2, 4, and 8. Factors of 12 are 1, 2, 3, 4, and 6, and 12. The greatest of those is 4, so that's why we divide by 4. So this gives us 10 thirds. All right, 10 thirds I'm going to do this method this time. 3 goes into 10 3 times. Remainder 1. So this should be 3 whole groups of 3 and 1 of those little pieces left over. Okay. What I'm going to do is just a couple, actually, let me skip these right here and let's go down and do 6 first, and then, because I'm going to run out of time on this tape first, so I want to make sure I get this. And then whatever we don't get done, I want you to do those on your own, okay? All right, so the directions on an instant oatmeal package say, combine 1 package of instant oatmeal with 2/3 cups of hot water. All right, so 1 package of oatmeal, I don't even know how you draw a package of oatmeal, and some water. Let's draw that in a cup. So this is 2/3 and this is 1 package. Now, Sophia wants to use 6 packages, so how much water should she use? Hopefully you said that you would use 6 times 2/3. If with 1 package I use 2/3, with 6 packages I would use 6 times 2/3. So let's do that. 6 times 2/3. Again, I'm going to use the method that they did where I'm not going to write 6 and 2 together in the numerator. I'm just going to cancel right here. All right, so the factor that 6 and 3 share is 3. All right, 3 goes into 3 once, 3 goes into 6 twice. Now I'm just going to multiply across. 2 times 2 is 4. And then there's only a 1 left here, so it's 4 over 1, which is 4. So she should use 4 cups of water. Okay, let's just do one of these, and then I want you to do these on your own. And your parents have the answer key, so they can check to make sure that you did everything okay. All right, so here we go. Again, I'm just going to look at these right here, and I'm going to say, what factor do 3 and 9 share? And that would be 3. All right, because the factors of 3 are 1 and 3. The factors of 9 are 1, 3, and 9. So 3 goes into 3 once. 3 goes into 9 3 times, sorry. And then I'm just going to multiply across. 1 times 2 is 2. And then there's just a 3 in the denominator here. So it should be 3 in the denominator. So 2/3 is the answer. Okay, so stop the tape here. I'm not coming back. You're just going to do these problems on your own and have your parents check. Again, make sure that you're doing the canceling first and then the multiplying. Even if you feel like it's a waste of your time, I promise you, if you don't practice this now, when we get to fractions that are really big, you're going to regret not getting comfortable with this method. So practice it right now before we get to big numbers. Okay, see you guys. Bye.